Okay, hi everyone. Sorry for being slightly late. Yeah, a few things surprised me a little bit, but I'm here. Of course, like usual, technical problems, but good that I finally managed to be live. Hi everyone. Sorry for. Just let me know if you hear me. I hope you do, and we can start. Just let me know in the comments if everything is fine. And yeah, in the meantime, hoping that everything is fine, let me tell you what's the plan for today. So two models. Love the cap. I got it from my CEO, so that was part of my birthday present. I waited for that present for 6 months. I got two of them. I got this one, and I have a second one, you know, GPU rich. But yeah, I guess given the fact that I only have one GPU, I will never wear it. Maybe at some point. All good. Okay, I hear, or should I rather say, I read on the chat that everything is fine, so we can start. Topics for today. A slightly different idea for the stream, but only slightly. So usually what we do is we cover mostly the topics that were part of the previous video. So previously we recorded the video about fine-tuning PaliGemma on object detection dataset. Apologies. And that will be part of this stream, don't get me wrong. But we also have new YOLO model. It was released, yeah, probably like 2 weeks ago, yeah? I'm too busy, so I didn't have too much time to catch up on all of those things. But we also have new YOLOv10 model, and the video is not out yet because, like I said, I don't have enough time to record all of them. And side note, maybe that won't be me who record the video on our YouTube channel for YOLOv10, but I still wanted to talk about it. So I still wanted to tell you a little bit about what are the outcomes of my tests, and do I like it, maybe how to use it, because there are slight differences. So that will be pretty interesting. But yeah, I want to start with PaliGemma. So let's do that, because that was the topic of the latest video. So let's do that. Let me just open up the collab that I created recently to fine-tune PolyGemma on object detection datasets, and I will tell you a little bit more about it. So yeah, the magic of cinema, everything works. Awesome. Yeah, let me just take a look at the chat. So everybody confirms you guys hear me. That's awesome. And what do we have? YOLO model can be used for TensorFlow tool if trained on instant segmentation. Hi Piotr, just like watching a celebrity. guys, you are being too kind. I'm not a celebrity. By the way, if anybody will be on CVPR, CVPR is in 2 weeks, or should I say a week? Sorry, a week from now. So just say hi if you will see me over there. Just a side note. Okay, so PaliGemma is a multimodal model developed by Google, or maybe precisely DeepMind team, but okay, let's say Google as a general umbrella. And it's pretty cool for multiple reasons. It can perform multiple tasks. So you can do like image captioning, questions about the image. So you can ask, okay, where is something? Is something over there? How many? Yeah, so you can do those things. It can do OCR, especially if you will use the higher resolution version of the model, because it came out in a few versions. Cargo, PaliGemma model card. Okay, so we have model card. A bit unusual, yeah, because Google decided, hey, we will release our model on Kaggle right now, which is interesting choice. Didn't saw that coming, but yeah, okay, it is what it is. So A baseline model is available in few versions. Pretty much the pre-trained ones are the three of those. So here, here, and here. Three different image resolutions. So this is the image resolution: 224, 448, 896. So that means that the image that goes inside the model is going to be resized into the square of that dimension, and then tokenized and then goes through the model. So obviously, if we would like to do OCR, then small letters probably better go for higher resolution, but you can do most of the tasks with pretty much the smallest version of the model. And what I showed in the previous, and you can find, the awesome part about it is that you can fine tune that model on your custom dataset, which is something that probably you always can do with those models. Just the problem is that usually you require a half of data center to do that. And over here, you can pretty much do it in Colab. Which is the awesome part about it, and we actually done that in the previous videos on YouTube. We went for object detection, so we showed how to do it for object detection. Let me just scroll down. Maybe you know what? Let's pick another collab that I was working on. Something a bit more ambitious. Oh, let me show you something like this. So here's another collab that I was working for. You can pretty much train that model to detect objects like you would train, I don't know, typical YOLO model, for example. But it is actually language model. Yeah. So if you ever worked with YOLO, you know that it returns usually matrices, tensors of numbers, and you just post-process those tensors of numbers, and that's how it works. Here is a little bit different because the typical outcome from model like this looks more like something like this. Yeah. Let me just increase it. Yeah. So you get the text, and the text is actually fairly hard to understand at first, at least. Let me just go to Hugging Face spaces first. So there are a few spaces on Hugging Face that show this model. But I like this one. This is the official one made by Big Vision team, which is the Google team behind the model. And the cool thing about it is that it shows you actually the result from the model. So if we would go for, let me just do doc image. Yeah, let's go for something like this. Oh, okay. Let's do this, and we would go detect. So the awesome part is that you actually prompt the model. Yeah. Hi everyone. Hi, SciCat. How are you doing? By the way, guys, where are you from? Because one of the things that I don't know is how to set up the hour of that stream. So I'm curious, are you guys from US? Are you from Europe, Asia? So that we would have a maybe better time for the video so that everybody can get here. So let me know in the comments in the meantime. So how it works is I can say, describe the image, yeah? And when I hit enter, it will probably give me like short description. Oh, that's interesting. Sorry, okay. I didn't expect that to come. That's the first time that happened to me. Okay, let's just increase that. Oh, now we're talking. In the image, I can see a dog sitting on a wooden surface. You know, you get the point. So you get the typical describe the image stuff. Turkey, India, UK, Brazil, Israel, Europe. Okay, so we have mixture of everything. Europe is there. South America is there. Jordan. Salam alaikum. Hello. Was the ID you just used VS Code? Probably no. This is Google Colab, man. This is Google Colab. and I use New York City. That I will be in New York City in 2 days. So if anybody from New York City would like to have a coffee with me, let me know. This is Google Colab. I actually don't use VS Code too much. I use mostly PyCharm. Okay, so you get the description for the image, yeah? Sure. But it's better. Let's upload maybe a different image, but still of my dog, maybe. Okay. You see, I need to come up with maybe new images. Oh, let's ask what's fun about the image, yeah? So you can ask VQA, you can do VQA, so you can ask question and get answers. That's interesting. I never so far had this problem, but it's interesting that it happens right now. But what I really want to show you is detection, yeah? So you can also say, use keyword detect. So say detect dog, yeah? And it will return you a information about the position of that object. Using this kind of unintuitive format. China, we even have people from China. So we have at the same time people from US and from China. That's, I don't know, 12 time zones or something like that. It's pretty crazy, guys. Thank you very much for being here. Of course, Onuralp from Turkey is here. Awesome to see you here. How to use inference fine-tune PaliGemma. So you are asking about how can you use PaliGemma within our inference package, just so I'm sure that I understand the question correctly. So in the meantime, let me just finish explaining. So it is the answer from that model is a text. So no matrices, no stuff that we usually get from our I don't know, YOLO-ish models. We get the text, and we need to parse the text to have the location, to have the bounding box around the object. And the awesome thing is that you can train that on your custom dataset, and I showed that during the video last week. And once you do it, let me just scroll a little bit lower. The model will pretty much produce long sequences. If you have a lot of objects on a single scene, it will produce a lot of sequences, and you need to parse those. And at the very end, you can even benchmark the model if you really want to. So we done that. Let me just scroll. And this is the confusion matrix that I got after training this model. So I got like 44 MAP on that model. So if you think about that, is it comparable to YOLO models? It's probably YOLO model can probably produce higher MAP than that on that data set, but it can do so much more. Yeah, so you can produce the bounding box, but you can also get the descriptions and so on. And the awesome thing about that model is also that you can do segmentation. So you can do segment, typo, segment doc. Yeah, so that's another keyword. It was detect, now it's segment. And when you run segment doc, you can get pretty much a fairly accurate segmentation of the object on the image. So that's pretty cool. That's PaliGemma. And now what else is there? So during the video, I didn't show segmentation because back then I actually thought that it's pretty hard to fine tune for segmentation, but spoiler alert, I'm working on segmentation right now. So maybe today, later in the afternoon, I will be able to show you fine tuning for segmentation using RoboFlow dataset. That will be pretty cool. But also what I want to show you is another thing. I posted about it on Twitter some time ago. So why I think that model is also interesting is because it limits the amount of models that you need to have in memory all at once. So think about cases like this, where I have a car that I would like to detect. Potentially, I would like to detect a license plate of that car. I would like to read that license plate. I would like to get a little bit more details about the car, for example, the brand, the color. So think about how many models would you need to typically run. Yeah, that's probably a lot, yeah, because even if you would use YOLO for car detection and YOLO for place detection, you probably would have two models because you would run the pre-trained COCO model to detect cars and fine-tuned model to detect license plates, so that's already two YOLO models. You would run the model to do OCR, so that's another model that you would need to run in the same environment. And I'm not even sure how you would get those. Either you would need to fine-tune the model to detect car so that it can distinguish between brands. That would be fairly complicated. And you can get all of that from that model. Yeah, so I was running those prompts in PaliGemma, and pretty much, of course, all of those information were got through separate prompts. So I ran a single prompt to detect car, a single prompt to detect license plates, single prompt to get the brand and the color, and then just concatenated those informations. But it's still super powerful idea that you can run a single model and get all that info. Okay, in the meantime, let me take a look at the chat. What MAP score is good to get on well-trained model? So it depends. Sorry, just there is I something just occlude a part of that text in the chat, and it was pretty hard for me to read. And on top of that, I'm dyslexic. Yeah, I always say that, so don't get mad at me if I would read your names incorrectly on chat or something like that. I'm doing my best. It's just super hard for me. So side note, how good is what is the good MAP? This is a very hard question to get. So Mohammed in the chat is asking that question, what is the good MAP? So I can tell you it depends. So if we go to YOLOv10, apparently new state-of-the-art object detector, we will talk about it in just a second. Let's take a look. Like what MAP are they getting? So they get MAP between like 37.5 and 55. Yeah, so that's good MAP for pre-trained model on COCO dataset. That's actually close to state of the art, depending. Like, I guess the paper claims they are state of the art. I'd say authors say it's state of the art. So that's a good MAP for this use case. Yeah, but if you fine-tune your model on your very small data set, you will probably like overtrain that model. It will be overfitted on that small data set, and then your MAP can be actually very high. And you can get MAP at around 80 or 90. And that's good. Sometimes it's actually something that you would like to get. If you have a very controlled environment, then you can have high MAP, and that's okay. I'd say usually when you have MAP around 80, 90 is actually kind of a signal that something is wrong, because in real life scenarios, you rarely get MAP this high. Like you see, this is the real life data set, COCO data set, and they have 30, maybe 55. So there's that. Can you please deploy your PolyGemma model? I can show you how I done that, but that's probably not the best way to do it. I know that we internally, because we have RoboFlow. We have RoboFlow inference, yeah. So I know that we work on PaliGemma integration. Something is here already, but it's I believe it's not yet entirely on production. But you will be able to fine-tune PaliGemma and deploy it through inference probably soon. What I did on the video, and I know that some of you also asked that question, like how do you deploy PaliGemma? What I did on the video is I went to Hugging Face, I forked that somehow. Where is it? Replicate. Clone. Oh, duplicate the space. Yes, sorry, Jesus, I am tired. I don't see, I don't see well right now. Duplicate space. I duplicated the space. Now let me just go. Let me just go. And then it's private, so that's why you don't see it on my profile. But let me just spin it up. And I just duplicated the space, replace weights that were loaded previously, those pre-trained ones, and uploaded mine, and that's how I. Yeah, I know, Honorable, duplicate. Sorry, I just didn't saw the button there, so it took me very long time to figure it out. And I replaced the path to pre-trained weights to my custom weights, and I deployed it through here. But I know that right now you can do it through transformers. But if you do it through transformers, you cannot train with the original notebook that the Google team released. You would need to train with the notebook that was released by Hugging Face, because also there is a duality right now. There is the official notebook from Google, and they use JAX to train that model over there. And most of the stuff that I built is also based on that notebook, so it's also in JAX. And there is another notebook that was released by Hugging Face team, and they obviously use transformers. So there are like JAX versus transformers, two versions of notebook. And generally speaking, you can convert whatever is in JAX into transformers. So even if you train with the JAX notebook, you should be able to run it in transformers. But this space actually use JAX, so they that's how they do it. Okay, yeah, nice. I see that mostly the questions were answered. So that's why I think that's a pretty cool model, because you can do so many things all at once with just a single model in the memory. It's pretty awesome. Okay, do you have any more questions about PaliGemma? Because if you don't, then we will go straight to YOLOv10. But I also don't want to rush it, so just let me know. I feel that I know something about PaliGemma. I'm not an expert because most that I know I learned from the original team. I pretty much DM them on Twitter all the time. But if you want to know something about fine-tuning PaliGemma, we can talk. So that's the moment where you should ask those questions. In the meantime, how do we know what the labels are? Is there a Coco names files? The question about Coco names, is that the question for PaliGemma, or is it the question for in general? On YOLOv10. So I believe that at the beginning when YOLOv10 was released, it was quite funny because the model only returned IDs, the index of the class. Okay, so in the meantime, if we already started to work to talk about YOLOv10, let me just go open our collab covering YOLOv10. So in the meantime over here, at the beginning over here, they didn't have class names. We can actually run that notebook. Why not? Why wouldn't we do that? Let's try to do it. So let me just spin up the notebook. It will take a little bit of time, but at least we'll have a way to play with that and maybe experiment a little bit in the meantime. And I will answer those questions about how do you know what are the names? Enralp said, I actually asked one about image embeddings. Let me just scroll a little bit higher. I didn't saw that. Sorry for that. I'm curious about also PaliGemma. What image embeddings usage do you think? Is it logical, for instance, accuracy, or just fine-tune and use it? I'm actually, so I can tell you like the architecture that they have is let me just it's a SIGLEAP plus Gemma model. Yeah, so PaliGemma. So in the meantime, we'll go into the YOLOv10 in just a few seconds, but this is the architecture of PaliGemma, yeah? So it's actually a SIGLEAP image encoder, and there is a text-based model Gemma 2B, and they are connected through this linear projection layer. So if you would like to use PaliGemma for image embeddings, it actually makes little to no sense, because if you want to do that, then just do SIGLEAP embeddings, because that model is pretty much, if the image component is pretty much SIGLEAP encoder, yeah? So if you would like to use that model to create embeddings, then just pick SIGLEAP. It's pretty much the same as CLIP, so it works the same, because text encoder and image encoder, and just use the image encoder from SIGLEAP, and that's it. And you can create embeddings this way. It will be way easier and more efficient, I think. So so that's what I suggest on a RELP. I mean, use extra with PaliGemma. I still not. I'm afraid there is a lag, like 30 seconds. So just let me know. I mean, use extra with PaliGemma, not use. Okay. Like I said, don't create embeddings with PaliGemma. Just use them with SIGLEAP. If the question is, can you inject embeddings from outside into PaliGemma, then probably not the best way to do that, because there is this projection layer. I guess I already closed the image with model diagram, but there is a projection layer. The projection layer is trained somehow. Yeah. So if you will replace SIGLEAP with different, or just inject your embeddings directly, that projection layer is not going to map correctly into the Gemma space, and that probably won't work. So I think if you would like to do that, then you would need to at least adjust that projection layer so that it would work with embeddings from different model, for example. Hey, I have worked with YOLO model to detect chessboard, but I want to improve it, detecting corners exact position, because the chessboard can be rotated. How can I improve it? That's, I mean, there are different ways to do that, to detect corners of the chessboard, but I think the overall, it comes down to very similar problem that the one I did recently with football AI model. So, of course, here there are more characteristic points that you should care about, but I would actually suggest to train the key point detection model if you want it to be super general and work in multiple cases. So, train key points, each corner have a different label, and just train something like that. And if it works on football, it will work on chess. That's what I think. But of course, you can also use a lot simpler approach that comes from traditional computer vision, that is an OpenCV. So there is something like that, probably, yeah. So you can probably do so with traditional OpenCV, but anybody who actually tried to do that with traditional OpenCV knows that it's actually not that simple if there are figures on the board. So I don't think so. So my suggestion, and some people will say that's overcomplicating the solution, but I think that's the easiest one. Well, I have the code for that for that thing that you see. I just didn't release it because I don't want to release that so that somebody else will create YouTube tutorial using my code, which already happened a few times. So I would like to release my code with YouTube tutorial so that I will be the first one who actually showed that on YouTube versus somebody else's doing that for me. So that's the reason. But you should be able to do it this way. I tried with OpenCV, but not working in most cases. Exactly, that was my experience as well. So I don't think it is actually a reliable solution. It breaks under so many circumstances that I don't really recommend that. This is, of course, a lot more work, but the reliability of that is much higher. So I highly encourage you to do that. We actually, not that I, this kind of RoboFlow stream. So if you go to RoboFlow right now, we actually allow you to annotate key points. So I have, for example, this field detection, and you can see how the annotations look like. Yeah, so you can annotate stuff. For chessboard, it will be way easier, because here I have like 32 points. For chessboard, you would have only 4. Yeah, so a lot easier. Okay, and we have the YOLOv10 loaded. By the way, of course, it's a fork of Ultralytics YOLOv8 repository, so that's why you, for example, have this meme situation where you do from Ultralytics import YOLOv10, even though that it's original repository and it's not Ultralytics, but it can get a little bit confusing if you're not up to date. I started this okay, Peter, can I connect with you offline? I mean, you can find me easily on LinkedIn or on Twitter, so just let me know. And I connect with so many people offline. I mean, I am super accessible, I think. So sure thing. Hello. Oh, we have another supervision contributor, Christophos, if I pronounce that correctly. Hello. You also experimented with heat maps. For football or for chess, I done really cool kind of like heat map chart for football recently. Let me just scroll it a little bit. Oh, this one. That's pretty cool. That will be included in the tutorial. I'm pretty proud of that. This took a lot of time to create, but I'm kind of happy about it. Okay, let's talk about YOLOv10. Some of you asked, okay, how do I map the IDs? Is there anything like in YOLOv10, V8, where I can get my names? I'm actually not sure. I think that right now there is something like, let's go model names. You see? So if you go from Ultralytics import YOLOv10 and then instantiate your pre-trained model, then of course this all assumes that you use SDK, not CLI. Then you just go model.names and you will get the names of the classes. And then when you have the result, and there are bounding boxes here, for example, but there is also classes. So you just go result bounding boxes classes. You get those IDs and you just map those IDs to the class names from here. So it works very similarly as it works with YOLOv10. Just to share, let me just increase the font, guys. I'm just too tired. Just to share, I ran the YOLOv9 and V10 codes to detect a custom data set, and the V9 results were slightly better than V10 was much faster. So how now the question is, and that's the main confusion right now, at least for me with YOLOv10, is how do you compare that? So my misunderstanding at the very beginning was, and I also was thinking that YOLOv10 is worse than YOLOv8 and V9, quite significantly actually. It is this way if you compare both, all three or both models on the same confidence threshold level. So here is my Hugging Face space. I highly encourage you, by the way, to upvote my Hugging Face spaces, because I'm looking, for a serious uptick of those likes after the stream. But nevertheless, let's run all three models on the same image. So I'm running YOLOv8, YOLOv9, and YOLOv10 on the same image. And that was something that I was also showing on the streams before and in the content that I shared online. Take a look. So what you see is the result. This is YOLOv 8 over here. This is V9 and this is V10. Everything looks great until you look for small objects. Yeah. So where are small objects? Probably in the distance. Yeah. So people, just because of the perspective, people in the background will be much. Hi everyone, Timothy. Hi Timothy. Thanks for joining us. So people in the background will be, of course, smaller because of the perspective. So let's take a look in the upper section of the image. And over here, for YOLOv 10, we see that there are groups of people here and here that are pretty much undetected. And YOLOv 9 is doing really well. That was one of the selling points back then when YOLOv 9 was actually released. Just give me a second. Is that it is actually better because of the few tricks in architecture and in the training at detecting small objects. So the comparison is especially strong where you take YOLOv 9 and you look at the group here, for example, where pretty much all of the objects are detected versus here where pretty much nothing is detected. So that was my first thought. Okay, it doesn't do well with small boxes. But if you would compare the probabilities or the confidences that are associated with those boxes, I'm not sure if I will be able to just zoom that much. It's probably the best I can do, guys. Sorry for that, but I hope you will trust me. If we compare, for example, this person over here. This person for YOLOv 10 gets only 46% confidence. Here it's for YOLOv 9, it's 71. Here for YOLOv 8, it's 73. So I was like, what the hell is going on? And reach out to YOLOv 10 team. And the explanation from their side is that the model is trained in a different way so that the confidence level that you usually would use should not be the same for YOLOv 10. So my typical confidence level that I use in my project is something between 30% and 50%. And I think that something is below 30 usually is probably not worth displaying because it's probably a lot of trash over there. But they say that because how they train the model, their optimal confidence level threshold is actually lower. And they say you shouldn't use confidence level between 30 and 50%. You should use something probably between 10 and 30. Yeah. So I say, okay, let's do this mental exercise, and let's lower the confidence threshold to, let's say, 10%. Yeah. And then run all three models. So just for comparison, now YOLOv 8 and YOLOv 9 run at 30%, I believe, and YOLOv 10 runs at 10%. Okay, and once you do that, I don't know, you can actually argue that you get high quality detections. I was looking for trash, for something that should not be here, for false positives. Of course, one of the main false positives that you see is obviously the frisbee that is over here that probably shouldn't. But other than that, those bounding boxes look crisp. Over here, maybe there is another one when two people are within a single bounding box. But just so you know, if you try to compare YOLOv 10, YOLOv 9, and YOLOv 8, they say you shouldn't do that with the same confidence threshold because it's unfair, because that model has lower confidence threshold that is optimal. So just so you know that. If you're comfortable with that answer, I don't know. I'm a little bit uncomfortable, but I also see a significant improvement when you do that. So there's that. And YOLOv 10 should be much faster because if you look at the repo over here, here's the latency. They have less parameters than other models, so they should be faster. They should be lighter. So yeah, that's what they say. And that's how I actually intend to use that model in my upcoming demos. And that's it. The important part is, and that's interesting also, you shouldn't run NMS with that model. So NMS, for those who don't know, non-max suppression. So typically you run non-max suppression. Wait, I don't want to do that. I have my own blog post about it. RoboFlow. How to code. That's my node. That's my code over here. That's my blog post. So NMS, for those who don't know, is a mechanism that allows you to do this. Yeah. So if you have double detections, NMS allows you to remove them, to clean the output. There are other strategies that you can use, but non-max suppression is one of the most popular. And typically you need to do that because models like YOLOv10, like RTM-det, like pretty much all models actually produce more bounding boxes than you need. Very often they have like a cap and they say, I produce 100 bounding boxes. And you need to figure out which are the ones that you care about and which are redundant and you should remove them. So YOLOv10 actually don't need NMS because it does not produce redundant bounding boxes, at least by design. So the upside of that model is that you only run the model, no post-processing is required, you just get the bounding boxes and you just go with that. So because they don't do NMS, they actually are faster on post-processing. And they have less parameters like we already established. So it should be faster. So for me, the only thing that is kind of like weird is that confidence threshold. Okay, let's go into the chat, see what people are saying. Have you tried deep LSD? Okay. Or similar line detection models for the soccer field? I actually didn't. I know that projects like SoccerNet, I believe. SoccerNet, GitHub. I know that they are using line okay, let's say, SoccerNet calibration. Yeah, that I believe that's the one. Do they have any visualization? Yeah, so I believe they are using lines. But I don't. I didn't use lines. I use key points. Yeah, they don't have a good visualization here. But there is a whole challenge on CVPR, so you can read about it more, but they use lines. I didn't. I use key points, but the whole idea for that project is that, hey, we added key points to RoboFlow. So now what can we do with key points that is cool? And I decided to do that. So, if I would use lines, that would defeat the purpose of the whole project. So the project started from, hey, I would like to create something cool with key points. My dataset is about cloud and has 4 cloud classes. Some types of clouds are very difficult to detect because they are very thin and the model blends in with the sky. Okay. What models did you try to use? This is a question to, I guess, Julien, if I read that correctly, because I might not. What do you think will be able to put the full code for the Pulver project? I hope I will put the full code for the football project something within the next 2 weeks. I will be on CVPR, so it will be a bit harder for me to work. So I can tell you, like, if no big model comes out, football AI is the next things that I want to do a video about. But if the new model comes out, I will probably work on the new model and everything will be moved in time. So I hope to do it as fast as possible, but I'm just a little bit scared to throw in some dates. I want to count cars driving by from a RTPS stream. What is the best approach? So I think that the best approach for you is to go to our channel, of course, because everything, you can find pretty much everything over there. And there are 2 videos that are interesting to you. The first video that is interesting to you is Wait time analysis. This will... Oh, sorry. Yeah, wait time analysis, because in that video we show you how to process a live stream and do it reliably and efficiently. So if you want to process RTPS streams, this is the video where we explain that. And another video is obviously our classic, where we saw how to track and count objects crossing the line. So you pretty much would need to combine knowledge from those two videos to count object crossing the line on the live stream. What else is there? Can you run YOLOv 8 and YOLOv 9 with lower confidence too? Okay, I can. I can, of course. You can also do that, by the way. If you go to Hugging Face Space and look for YOLO Arena, you will be able to do it. So that's what you have. That's what you have. Yeah. So if you will run YOLOv 8 and V9 at lower confidences, this is pretty much what we are getting. Now you can argue which one is more precise. Yeah, at this point, all of them detect pretty much all of the people. It's just about those extra things, like handbags and backpacks and all of those things. We have also other images, so we can try to run this. I remember that at lower confidences, those other models produced weird results for this particular image. So here's this image. And sorry, we just need to lower the confidence thresholds for all of them. So the question was from the chat, what if we will lower the confidence threshold for all of them? Maybe that's what we should do, which we actually shouldn't, because we will get a lot of trash. And you will see that. Okay, so YOLOv 8 at low confidence, they still don't detect those cars over here. You probably don't see that. There is a small car and there is a truck over here. And even at 10%, they don't detect that. Of course, this is only one image. Okay, so remember, we cannot judge the model based on one image, but I'm just showing that as an example. Yeah. So on the other hand, YOLOv 9 is actually getting all of those. So all three of here, and it's getting extra detection of something that probably shouldn't be here. So that's a false detection, but it also detects a driver of the car over here. So like I said, YOLOv 9 really good at detecting small objects. And YOLOv 10 is getting the result that I would expect. Yeah, all cars are detected. The class is okay. So there you have it. So that's the comparison for all of them at 10%. What models are generally good at line drawing, like electric circuit and circuit boards? To be honest, I have almost no experience with line detection models, so I don't want to bullshit you guys. I don't know. If you want to, we can try. I can try to create content about that. But bullshit aside, I actually don't know what models should you use for those use cases. Never done any. For symbol detection in documents, which models should perform better? I mean, do you want to do symbol detection, or you just want to read the text? Because I would say those are two different things. Would you like to pretty much do OCR and detect the whole text, or just one symbol at the time? Because we have users on RoboFlow that try to detect each symbol separately and then try to combine that in the whole text. There are libraries like EasyOCR or Tesseract that I used for object character recognition. Lately, to be honest, I'm just using LLMs and or LMMs or VLMs, yeah, and I just pass the image and tell it to read the text. That's pretty expensive if you use those enterprise models, like, I don't know, GPT-4 Vision or something like that. But I actually tried to do OCR with PaliGemma. So you see how we go back to PaliGemma at the end of the stream. So if I go to Spaces, back to Spaces, and once again talk about PaliGemma. I believe Merv did a space for PaliGemma, probably this one. And they have this use case, for example. So reading text, here is the receipt from the, I'm not even sure what the receipt is. Like, let's have some information about the Wi-Fi address, whatever. Okay, but there was a question. What is the password? And the password is here. It's AAEU, and yeah, PaliGemma is capable of extracting that information. But we can go even beyond that. Like, what's the URL? So you'll see the URL is here, like http hello.wifi, for example. And you see it extracted the URL correctly. So lately, I actually started to use LMMs to read text, and it's even better because you can get more information from that. So not sure if that's what you are aiming for, but this is pretty cool use case. Yeah. How fast is YOLOv10? Training, fine-tuning. It seems that every new generation only gets more complex, and for me, the small performance boost doesn't justify the complexity. And I actually agree with that. Like, you know, if depends on what you do, but if the training is super long, maybe that's not worth it. By the way, PaliGemma trains really fast, which is another interesting thing, is that you actually can get good results fairly easily. Let me just take a look. I'm not sure if I kept the logs here. Didn't felt very, very long, to be honest. Is there a time here? I'm afraid not. But it's around 20 seconds per epoch, where we have, what was the data set here? 2 more. I'm not really sure how many images there is in the data set. Let me just take a look, okay? Not this one, this one. Okay, so the data set has like 1,500 images. And I trained the small version, or even the nano version. Let me just take a look. I trained the nano version, so that's probably not very representative. But it was only 20, maybe 30 seconds per epoch. It was fairly fast. I don't think that it was slower than YOLOv8 during the training. That's for sure. I'm not sure if that's the answer that you are looking for, but I think that it was fairly fast. So I didn't complain about the speed. It was a bit unstable, in the sense that when I was doing that tutorial, a lot of things did not work in that repository because it was super fresh. So when people started to use it, a lot of bugs came out, but the speed was actually okay, the speed of training. What is the best way to detect the angle of fruit lying somewhere? Angle of fruit lying somewhere. What do you mean by that? What is the angle of fruit? It's like how it's rotated. If that's the case, if you think about how it's rotated, you have 2 options. You can either go for oriented bounding boxes. Okay, let's go with ultralytics. So it's something like that, where you can get a tight bounding box around the object. Or you can do just segmentation, and OpenCV has like it's probably not that, but you can also use OpenCV to then have a tight box around the mask. Yeah, that's not it. But OpenCV has also a method that would give you a bounding box around that. But probably oriented bounding boxes, and then you get the angle for free. Does the Nano work on Coral dev board? I actually don't know. I have Coral dev board in my drawer, never use it, so don't know. Sorry for that. So if that, yeah, Lawrence said that's what he meant by rotation. So I would say, yeah, oriented bounding boxes, or just go for segmentation of the object and then get a tight box around that segmentation using OpenCV. My project is to detect pointer analog gouge and read the gouge. I can detect the gouge, but I have challenges in detecting the pointer. Any suggestion? Okay, so there is like this, and it rotates, and it can be something like that, and you could detect the angle. I think that oriented bounding box could work for that. I think that if you would annotate with your rotated bounding box and train the model to do that, you could read the angle, and from the angle you could estimate the value. So I think that it makes a lot of sense to use oriented bounding box for a case like this. YOLOv10 looks promising from your results. Still prefer the design of RT DTR, seem more simple and design more aligned to hardware optimization for elements. I know that RTDTR is a pretty cool model. I used it, I believe, in PaliGemma library, and I know that transformers were adding or already add RTDTR to transformers library. I don't blame you. It's a pretty cool model. Completely different architecture, but yes, I used it, and PaliGemma was kind of impressed. In PaliGemma, I believe it was MIT or Apache, and for models with very permissive licenses, RTDTR was pretty awesome choice. So not very surprised. How can I design system that integrates a large language model LLM with meta segmentation, segment anything model to track and segment objects in video, such as counting the objects? Man, you could use set of marks. Set of mark. Jesus. Okay. So if you would like to use LMMs with segment anything model, then I believe that's the way you should go. So set of marks is doing something like this. You use segment anything to segment the scene. You filter objects by size, and then you use that that mask to create this annotation, and you annotate the image with segment anything. You create those numbers, say, okay, this image is number 1, this is number 2, etc. And then you take that annotated image and you pass it to LMM model. And if you do that, and I will need to scroll a lot to get to my experiments with set of marks, but I had once done something very, very similar. Then what you will see is that the model very often understands those marks, and you would be able, it will be able to interpret that, and you will be able to ask additional questions about those objects on the scene that have specific labels that you created with segment anything model, for example. I'm getting closer. Sorry for all the scrolling, but if I get surprised with questions like that, I know that I have the answer on my Twitter. I just need to scroll. I just need to scroll the hell out of it, but I'm getting closer right now. Oh, yeah, there is it. So I was experimenting with set of marks. I mean, it was not the official implementation, but I done the same with segment anything. So I would just use segment anything to generate those masks, filter all the trash, and then use the rest to annotate. And I was asking question, and how many red apples do you see? Which apples are red? You see, so I created those labels, sent that to the language model, asked the question, and I got the answer. There are 6 apples that appear red in the image. These apples are labeled with the following numbers. And that's how you communicate. So you create those labels and then you ask questions, and then LMM use those labels to answer those questions. And it said 1, 3, 5, 6, 8, 9. And if you analyze the apples that are red on the image, those would be those apples. So I think that set of marks is a real cool idea to integrate like segment anything model with LMMs. Christophos is saying that method is CV2 mean rect. So that's the method that you can use to get, yes, that's the method that I was looking for. So like I said, oriented bounding boxes or segmentation model plus OpenCV, and you use mean rect to get the rotated bounding box, and that should be fine. How can I detect when the toilet lid gets raised? Asking for a friend. I'd say that you can do it with object detection. You just need to have a lot of images of raised and unraised lid, and just object detection will be fine, or even image classification. I'd say you just need to annotate a hell out of images of toilet to do that, and you should be fine. Hello, what are you doing? Why did you set LLMs instead of LLM? Okay, there are differences. LLMs are large language models, and LMMs are large multimodal models. So LLMs only take text and produce text, and large multimodal models take like text and image and produce text, for example, or text and audio and image and produce audio, whatever. Yeah. So LMMs are much more powerful because they can take more. So if you would like to do that, you cannot do it with LLMs, but you can do it with LMMs because you need to be able to pass the image and the prompt. What else is there? Let me just take a look at the chat. By the way, we'll be finishing soon, guys. So I'm just letting you know we are already 5 minutes past the time. But let me just take a look at the chat. Fine-tuning of VLMs is better than fine-tuning of YOLO model for objects using set of marks. You can fine-tune. So fine-tuning like PaliGemma, for example, is awesome because when you fine-tune YOLO, for example, and you have the pre-trained model and it has those 80 classes, the moment you fine-tune on your own classes, it forgets all the previous classes. So you had 80 classes, but now you trained it to detect, I don't know, license plates, for example, and now it only can detect license plates. For PaliGemma is awesome because you fine-tune PaliGemma on license plates dataset, and it still can detect cars and license plates. So that's pretty cool. And I think that set of marks, if we talk about that, it was an idea how to use those multimodal models to detect stuff when detection was not yet possible. Yeah, and now it's possible. So I'm not really sure if set of marks is still a needed project, but maybe. I'm not sure. Large multimodal language models. The moment you say multimodal, it can be language and more. So I'm not sure. I'm not sure. You can call it whatever you want. As long as we all know what we are talking about, it's all fine. Going back to the fruit question, I understand the angle part, but the angle does not provide directions such as for the angle is 0 if doesn't not provide directions such as if an angle, if 0 is that not say top part object. No, it does not say which is up and which is down. Yeah, so you only will get an angle, nothing more than that. It does not differentiate between this and this. So you're right. If you would like to know that, it's probably you would need to have something extra to resolve that. And I don't know, combination of object detection model to understand the position. But the oriented bounding boxes, I still go for that. You just need to have something extra on top of it. Can you also make a video about model interpretability? Maybe on YOLOv10. I actually done my thesis on interpretability, so probably I could do that. I was doing all the grad comms for my thesis, so yeah, probably could. Not sure if people are interested in model interpretability at this point, but if you really want to, I could do probably a video about it. You know a better method than NMS for processing the predictions on multiple small tiles that are Is that a question from somebody from supervision community? Moritz H asked, is it a better method than non-max suppression to post-process predictions? I'm not sure if it's better, but I know another method. We actually released supervision today, new version. And in the release notes, if you would go here, we introduce new method. We call it non-max merging. So for those who know how don't know how non-max suppression works, it's like if you have those double detections, non-max suppression looks at confidence levels and said, okay, I will pick the one with higher confidence level and I will discard the other one as long as they are the same classes, although there is also something called class agnostic non-max suppression, but doesn't matter. And non-max merging says if the overlap is high, then we are going to merge that into larger bounding box. So not discard the other one, but create a new one that, you know, is large enough to contain both of those boxes that you merge. So that's an alternative. And I think that if you talk about doing tiling, so the Sahi algorithm, we also support that, but we call it we call it inference slicer. Let me just open up a visualization from the previous release. We are doing a lot of scrolling this time, guys. A lot of scrolling. Do I have a visualization? Wait a second. I will show you guys something. I just need to look for that. I just post on the internet. Definitely too much posts on the internet. Then when I try to find something, it's a very problematic situation, but it should be easy to find it now. Oh, so if we talk about tiling like this, yeah, where you go one by one and you detect objects, sometimes there is an overlap between those boxes. So you get double detections over there. And the question is whether or not non-max suppression is the best strategy to solve that. And in my experience, no, it's not the best strategy. It's actually better to use something that would merge those boxes. So right now, in supervision, we support that case. And instead of discarding those extra detections, we actually merge them. So that's what I would suggest. And you can do that already with supervision. Latest release. Highly encourage you to do that. What else is there? Which one is better to observe color changes, YOLO or UNet? I actually think that if you want to observe color changes, you just need to have a mask of an object, so some sort of segmentation object, so that you precisely know where the object is, and then you just do like traditional computer vision. You just calculate the colors, average colors, mean colors, you know, you just be clever about it, cluster by color. But I think that segmentation is a lot better, because I tried to do something like this with bounding boxes, and when you have bounding box and the object is within the bounding box, you get a lot of background. That's an extra color that you don't want to have. Alternative to do that is to use embeddings. So if you just do detection and you calculate vectors, and you don't talk about colors per se, but you will be able to observe the change because the vector value will be changes. Thanks for the content. Can you suggest what's the best way to achieve end-to-end tracking of baseball players with same track ID? I mean, I use ByteTrack, but ByteTrack is actually not the best tracker. But just a suggestion on something that you can try if you would like to track players, not necessarily baseball player, by any players. There was a new tracker released recently. It will be on CVPR 2024, and it is called DiffMOT. It's using diffusion models underneath to get the tracking, but it's apparently very good at not mixing those IDs. So even if players overlap themselves quite significantly, you should be still able to have the consistent tracking ID. So it's pre-trained for sport use cases. I think that you should try it on baseball players if you want to. Yeah, if you want to track baseball players, I think that's one of the best choices that you can go for right now. Thanks a lot. Highly appreciate the conference. My pleasure. My pleasure. Have you considered making a video about running YOLO on mobile phones? Not really, but I'm not really sure how many people would be interested in that. If we would have a lot of people interested in that, I could do that. Probably not now, because there's a lot of models being released and we have a lot of content ideas. But you know, very often during the year, there is this part where models are being released all the time. And there is this part where no models are released. And we can actually consider making video like that during the off season where there is not a lot of models being released. Thanks a lot. Yeah, their inclusion weren't handled well. Yeah, because so thanks a lot. The confusion were not handled well by ByteTrack. So ByteTrack does not handle occlusions very well because it's only using bounding boxes. No extra information about the color, shape is taken into account. So if something is overlapping another object and those two bounding boxes are heavily overlapping, there is like 50% chance you will lose that track. So I really don't think ByteTrack is the best choice for sports use cases because there is a ton of overlap in those cases. How I need to solve a mission which involve position detection. The mission requires developing algorithms to estimate the position of a flying drone using camera images. How would you solve that? Oh my, and that camera is looking up into the sky to figure out where the drone is. That would be pretty complicated task to do, honestly. Really good session. I'm glad you like it. I need answer about running it on Coral Dev board. That's possible. I don't know. Coral seems very low compute. So if anything would be possible, then I think the Nano model could run there. I'm pretty sure Nano could run on like Raspberry Pi. Yeah. So now the question is, what is the compute capability difference between Coral and Nano? But like I said, if anything is possible, then I would say the Nano version. But Coral, I believe, used TensorFlow. Do you need to have TensorFlow model for Coral? I don't know that. Please make a video about mobile. Okay, so like I said, if no models will be released, then we can talk about video about running the models on mobile. I'm just not a mobile developer, so making video like that for me will be a bit problematic because I don't know iOS. So it will be very challenging video for me. What about for tracking an object from UAV? Would byte track or diff mode be good? I think that if you want to track, so depends if you want to track on board. Because if you would if you would like to run the tracker and the detector on board of that drone, then you probably would need to run that on very low compute, and ByteTrack is good tracker to run on low compute. If you will run offline, it actually doesn't matter, and probably both can be used. Probably diff mode will give you better accuracy. You just need to ask yourself a question: do you care about that accuracy that much? Because ByteTrack will not break until there is like a large amount of occlusions. So if somebody will, I don't know, hide under something and you will lose him for quite a significant time, ByteTrack will definitely not regain that tracker ID, but maybe other trackers will. So depends on your specific use case, I think. Piotr, maybe we can suggest new Raspberry Pi 5 AI. I actually didn't use that. Not sure if that's a good hardware to use. To be fully honest with you, I have like a full drawer of those boards. Most of them didn't use, so I need to think about. I even have Jetson AGX Orin, this new super powerful board from NVIDIA. Need to think about some demo projects that I can build with that board. Okay. I think that's a wrap. We are already 20 minutes above the initial time constraints. Thank you very much, everyone, for being here. That's our fourth community session. I think we have like a steady amount of people coming to those community sessions, which it makes me super happy, because the worst thing that can happen is there is nobody to talk to during those sessions. So thank you very much for being here with me. And yeah, I'm not sure about the next community session because I'm flying to US for a few weeks, so I will be off. And I really would like to record those at home, not on the road, but I will be on CVPR. And it will be pretty hard to make live streams from there. But yeah, thank you very much for being here. I hope you like it. And if so, leave the like, comment, let me know in the chat that you liked it. And I see you next time. Not sure where that be, but probably in more than 2 weeks. So stay tuned for the demos on social media, because the YouTube will not come very fast right now. Okay, thank you very much for being here once again. That was a pleasure. Yeah, and I see you next time. Bye.